Okay, we're going to be solving question 6, the Fourier series, given the periodic. So the question is, given the periodic non-sinusoidal voltage shown below, find the fundamental frequency of Vs. Okay, so the first things first, we're going to be solving the frequency of Vs. So how do we do that? We're going to be using our formula, which is equal to, like, our fundamental frequency is equal to 2 pi over t. Now, what is t? T is the period, and the period is basically from peak to peak. So if we look here, it's 1, 2. Therefore, the period is equal to 2. And we plug that back into our formula, 2 pi over t. And 2 pi over t is equal to 2 pi over 2 is equal to pi. Cool? Cool. Now we're going to move on to part B. Find the DC component of the Fourier series for A0, which is, whatever. So the way we solve this question, all you have to do, there's a simple formula. Whenever it says to find A0, which is A0, we're going to plug in this 1 over t, the integral from 0 to t, and the function delta t. So now, the question is, how do we know what our ft is? So we simply go back to our graph, or our sinusoidal. It says it's 5 volts, it goes to 5. We just write that down. So we said our formula is 1 over t, which is, we found it to be 2 from. So here's the thing now. Since we're finding it from 0 to 2, from 0 to 1, we're going to have something that's the same, and then from 1 to 2, we're going to have something that's different. So we're going to have to break up our period from 0 to 1 and 1 to 2. The reason why is because from our peak to peak, right, from here to here is one equation, and from here to here is another equation. So the equation from here to here, from 0 to 1, we go back here, from 0 to 1, we have 5. The way we know that is because we look over here, it says 5 over here, and it continues for one period. So we write that down, 5 dt, and then our second equation is we go from 1 to 2, and that's, we see over here, our voltage is only 0, so we write down 0 dt. So now what do? We have to take the integral. So the integral of 5 dt is simply 5 t over 1. You don't have to write that. And it's going to be plus, this part is 0. You know, the derivative of 0 is 0, so you don't have to write that. And then we're going to take it from 1 to 0. And then this is also going to equal to, just plug in 1 over here, 5, 1, minus 5, 0. Therefore, it's equal to, this is just equal to 5, so 1/2 of 5 is equal to 2.5. Cool? Cool. Now that's our answer for part B. Now let's go on to part C. Okay. Find the coefficient for the cosine component of the Fourier series. So now, to solve the coefficient of the cosine series, you know, we have an equation for that. And the equation, the very first thing we're gonna do is we're gonna change the period in terms of pi. And how do we change, like, the period in terms of pi? So there's a formula. This is the formula you use to change the period in forms of pi. So it's 2 pi over t. We already solved for t, so it's 2 pi over t, which is 2. So therefore, it's pi. But this is not a new period. Our period is always equal to 2 pi. In terms of cosine or sine, it's always equal to 2 pi. That is our t. But what did we do over here? What is this number, this pi? This pi is, before we had a graph, a graph, and we had numbers like 1, 2, 1, 2, blah, blah, blah. But here, what we did was we found the parts, like, how do I say, what is, like, we found, like, instead of 1, this becomes pi. So therefore, it becomes pi, and then this becomes 2 pi, this becomes 3 pi, etc. So what this is, this gives us like the terms here. Cool? Cool. Now what do we do with this newfound knowledge? We know our new period is 2 pi, and our formula for the cosine component is an. That's what it's asking us, find an, right? So it's an is equal to our new period, which is 2 pi, 0 ft, which is the function, cos n omega o t dt. Now, how do you solve for omega o? We already did solve for that. Omega o is simply 2 pi over t, and that is 2 pi over 2 is equal to pi, and there we go. We solved for our omega o. This is my bad, I should have simplified it here. This is omega o. Cool? Cool. So now we can just start plugging in everything. Okay, but before all of this, we have to look back at our graph. So now instead of 0, this is pi. Yeah, give me a second. This is 2 pi. This is 3 pi, blah, 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 and so on. So from 0 to pi is going to be our first equation, and then from pi to 2, pi is going to be our second equation. So like we can go back and start drawing, rewriting our equation, which is an, and then we said from 0 to pi, and we know our voltage is 5 at this time. 5 cos, we don't know n is a constant, we're just going to treat it as a constant when we're going to take an integral. The omega o, which is pi, and then t dt. Cool? Cool. And now we're going to take the integral of this. Oh my bad. Then we're going to do the integral of the second part, which is going to be from pi to 2 pi. But because we know that the cos of 1 is 0, we just make this whole thing equal to 0 and we just get rid of this shit. Cool? Cool. That's what I like to hear, man. Alright, so now we're going to be taking the integral. I forgot one thing. So this is 1 over t, and we said t is 2 pi. Cool. Alright. Now what we're going to do is we're going to be taking the integral of this. How do we do the integral? So the integral of cos is sine n pi over t, and for this n we just have to take it and put it below our 5. That's how we do it. That's it, man. And then we just have our integral. Oh, what the hell am I doing? Blah, blah, blah. Okay, yeah, that's it. And then we take it from pi 0. Solve this, and you're gonna get like you're gonna find the cosine component of this question.